All right, to start out with today, guys, we're going to take a look at a review problem from what we did yesterday. So I want you to try this warm-up. It's x equals y minus 8, and 3x equals y minus 16. So give that a shot, and then we'll go over it. All right, so we're solving this equation, two equations. Which two letters do we need to solve for? Yep, x and y. So when we're done, we're going to have x equals, we'll get a number. We're going to have y equals, we're going to have another number. Okay, one way we can do it is graphing. Right? That's what we did on Monday. What's the name of the other technique we learned? Begins with an S. Substitution. Okay, right? Think about like a football game, right? When they substitute a player, that means they're going to take one person out and they're going to put a different person in. Okay, they're going to substitute. All right, so with substitution, first step is look at each equation. You're going to take one of those equations, and in one of them, you want to get a letter by itself. If that's already done, we're good. Okay? Is there an equation, either the top one or the bottom one, that has a letter by itself on one side? Okay, which equation is x by itself in already? The top one. Okay, the top equation already has x by itself. Okay? The bottom equation, no, x isn't by itself. There's a 3. Y is not by itself. There's a minus 16. Okay? But in the top equation, x is already by itself on one side. There's nothing else on that left side except an x. Everybody see that? Okay. So now step 2. Look in the equation below. Do you see an x anywhere in that bottom equation? Right next to the 3. So what we're going to do is where I just put boxes around those two things, we've got a formula for x. What does our formula tell us x equals? X equals y minus 8. So in this bottom equation, you're going to take x and you're going to change it to y. You're going to change it to y minus 8. That's the substitution part. Everything else stays exactly the same. So in fact, what I'm going to do is copy it all down first. Put a 3. Leave a little bit of space, because that's what you're going to change. Okay. Keep the equal sign. Keep the y. Keep the minus 16. Okay, we're just changing what's next to the 3. Okay. Who can tell me again, what do I plug in for x? Plug in y minus 8. Now, look at the equation we just made. How many different letters are in that equation? Just one. The only letter in this equation now is a what? Just a y. Okay, before, look at the top equation. It had x's and y's. Look at the bottom equation. It had x's and y's. Now we have an equation with just y's. Okay? That's what substitution does. Gets rid of one of the letters and makes it so we just have y. All right. Now, the reason I put this y minus 8 in parentheses is because what happens with this 3? There's a property, begins with a D. Distributive, right? Okay. Mr. Rice talked about this a lot. What kind of number is the 3? Is it positive or negative? Positive. Positive. How do you know? Yeah, if it was negative, it'd have a little minus. Okay? So now we're going to distribute. Okay. What's 3 times y? 3y. Now we've got 3 times a negative 8.
Negative 24.
Good. Negative 24. Okay? Right-hand side, keep it the same. Okay, everybody okay so far? Yeah. All right. Okay, next step. Let's get all the y's on one side. Okay, so I think the easiest way to do it is take the y that's on the right, move it to the left. So yeah, go ahead. How would you do it? Minus y. Good. Good. Okay, minus y. Minus y. What happens when you do y take away y? Like 5 take away 5 or 3 take away 3. It cancels out. And now on this side, that was good. 3y take away 1y. Leaves you with 2y. We still got that minus 24. And what do we still have on the right-hand side? Still got negative 16. Good. Okay, we got 2 steps left, and then we're going to know why. Justin, I got all the y's on the left. I want to get all the things without y's on the other side. So how would you get negative 24 on the other side?
You subtract it. No, you add it to 16.
You add it. Why do you add it? That's good. Good catch. Right. Okay. Negative 24.
68.
Positive 24. Go ahead. What'd you say? That's like 24 take away 16. Think if you've got $24 and you spent 16, how much would that leave you with? Yeah, leave you with 8. So you put it in terms of money, everybody gets it, right? All right. It's like 24. And if you get stuck, okay, use your calculator. Okay, you can use calculators on the test. Okay, I got one last step. Yeah, Laura? Divide each side by 2. Okay, who said 4? 4, Ben. You got it. Y is 4. Okay, that's the hard part. Okay, that's the hard part. Now we get the easy part. Any questions on how I got 4? Okay, Savon, you got that?
Yeah.
You got it? Okay, I got y. What else do I need? I still need x. Do I have a formula anywhere up above that can calculate x for me? Yes. The top one. It says to get x, take y and subtract 8. Okay, so what am I going to do? You're going to take 4, and you're going to plug it in for y. Okay, I asked you guys this yesterday. Why didn't we just do that right away? We didn't know what y was. We couldn't do it right away. Good. Now we've got y. We're going to fill it in, and then we'll get x. Okay. Just tell me, what's the right-hand side going to say once you fill in y? 4 take away 8. Okay, what's 4 take away 8, Travis?
4 take away 8,
negative 4. Okay, remember, 4, pretend you have $4. You're going to spend 8. You're spending more than you have, so you're going to go debt. You're going to go negative. Okay. Are we done now? Yes. Now we're done. Okay? That's exactly how every substitution problem works. Okay? Even the ones we do today. Question?
I did it a lot differently, but I still got the same answer.
Yeah, there's more than one way to do it. In fact, okay, I'm going to be honest with you guys. Substitution, okay, is good for these kind of problems. In math, when these problems start to get harder, substitution is not a good way to do it. Okay? The reason I'm teaching you guys substitution is it is a good way to do these. It's simple. Okay? Everybody okay with that warm-up? We're good? Anything else anyone needs to copy down? Okay. So, every problem we did yesterday, which letter is already by itself here?
Y.
Y. Which equation? Top or bottom?
Top.
Top. Okay, we were all set. Which letter is by itself here? Y. Which equation? Top. Okay. There was already a letter by itself. Okay, so now we're on the side of your notes. Mr. Roy and I are going to pass this out. This part, I just want you guys to read.
Yeah, no, it's just going to be we're just giving you the back, we're just giving you the back, tomorrow, this was going to be notes yesterday because of the fire drill and stuff. We didn't get to this. All we're doing is, we're just doing some examples today, all right? There's no real writing involved, just examples. Understand, let me give you fair warning. On the test, we're going to tell you tomorrow afternoon, at the end of class, there will be examples on the test tomorrow, on Friday. So that means you guys that sit there with your thumbs up your butt and don't write anything, I suggest removing thumb from butt, putting hand on pencil or pen, and writing example. Understand? Got me? Good.
Okay, and the example on the test. Okay, guys, the example on the test is not just write the answer. It's show the work, write the answer. Yep. But as long as you copy down what I put on the board, that's all you need.
So guys, understand, like Mr. Hager was just saying, substitution, it's hard. It's one of the more harder things that we've done so far. If you understand it, great. But don't disrupt other people that don't understand it from understanding it. That means like talking during class, being disruptive, that doesn't help. Give yourself a chance to understand it. Don't give up. Yes, it is hard. I understand that. But all Mr. Hager and I are asking you to do is try. Just try. That's all we want you to do. But some of you guys, if you get to it, it's a little bit different than what you've seen. I can't do it. No, can't do it. Give it a try. I know it's hard, but give it a try. That's all we ask you to do. But an honest effort, not like, oh, I tried, I just wrote down a couple of numbers. That's not trying. That's a BS effort. You guys know what BS stands for. Okay? So, again, try please. Alright? I want you guys to give it a try. All examples need to be written down today. Because it's unfortunate the people who are not writing the examples are the ones when I look at Mr. Hager's grade book and we review how people are doing, those are the ones that aren't writing the examples. The ones that really need it aren't taking advantage. And the ones that maybe understand it and talk while I'm talking and are super disruptive, then we have a problem. Okay? So write the examples down today. Give it a try. If we give you time to work on stuff during class, work on it. Don't just sit there and say, I don't know what I'm doing. Give it a try. Okay? So Mr. Hager and I will be very thankful if you do that. That's your job. That's what you need to do. All right?
All right. So we just went through, okay, each example. And I showed you that step one was already done. Already had one of the equations with a letter by itself. Whether it was x by itself, y by itself, y by itself. Now the next couple examples we're going to look at, we're going to have to do that step. But once we do it, everything else is the same. Taking and plugging it in, doing the distributive property, combining like terms. Everything is the same. We still got to find x, we still got to find y. We just have to do step one. Okay? And we're going to make it so that it's obvious. There's going to be an obvious way to do it. Okay? You're going to know which letter you should try to get by itself. Okay? Let's look at this one. Okay. So does the top equation have a letter by itself right now?
No.
No. How about the bottom equation?
Yeah.
There's a letter by itself on one side with nothing
Let
else?
Mr. Hager say it on the left-hand side, the left or right-hand side. Usually the left-hand side, he's asking, is there a number and then the equal sign? Sorry, is there a variable by itself and just the equal sign? Do we have that?
No.
No, not at all. Good.
So now, we have basically four choices. You can pick the top equation, or you can pick the bottom equation. If you pick the top equation, you can say, all right, I'm going to try to get x by itself, or I'm going to try to get y by itself. I think one of those options is easier. If you pick the bottom equation, you could say, I'm going to try to get x by itself, or I'm going to try to get y by itself. So let's decide which equation we should pick. You want to start with the top or bottom?
I think the bottom, because it'd be much easier just to subtract y. Let's get 2x by itself.
Okay, so we could, remember, you want to get the variable that has a coefficient of 1 by itself.
Add 4y.
Yeah, I like that idea better. So I like that idea. Start with the top equation, okay?
But guys, understand that you don't have to use the top equation. If you can figure it out to get a variable by itself on the left-hand side of the equal sign with the bottom equation, that's fine too. Right? You don't have, there's a ton of different ways you can do these.
So Sivan, can you tell me again, what letter are you going to get by itself here?
You variable?
Yeah, which variable?
X.
X. How are you going to move this to the other side?
And then add 4y.
Perfect. You're going to add 4y. And you're going to add 4y. Are those like terms?
No.
No. So can I combine them, or do I just have to write it out? Just write it out. What's on the left side now?
X.
X equals, what's on the right side, Sivan?
17 plus 4y.
Good.
Hey guys, understand that this isn't slope intercept anymore. So, it doesn't matter, it doesn't have to follow any particular order. As long as the x or the y is by itself on the left-hand side, you're fine. Doesn't have to follow, the x doesn't have to be in a certain spot, doesn't matter. It's any order you want.
Okay, everybody see now we've got a letter by itself.
Yeah, guys, 4y plus 17, it's the same thing. If you did it that way, that's fine too.
Yeah.
It means the exact same thing.
Everyone see how we've got x by itself now. Guess what? From here, it's the same thing you did yesterday. Same exact thing. Okay? Look at the second equation. Do you see an x anywhere in that equation?
Yeah, 2x.
Okay, 2x. What I'm going to do, I'm going to put a box around it. Okay. Do I have a formula that tells me what x equals?
Yes.
What does x equal?
17 plus 4y.
17 plus 4y. So what am I going to do with 17 plus 4y? Think about it for a sec, Dominic. Yeah, you're going to plug it in for, what'd you say? Yeah. We're going to take, and we're going to put it right there. Okay, so first thing I'm going to do, I'm going to write down everything. I'm going to leave a space. And what do I want to make sure that I write in? So if I have to do a distributive property, I don't forget. Parentheses, good. So 2, leave some space because you're going to fill in something that we just wrote an arrow for. Still got the plus y. Still got the minus 2. Okay. Ben, what am I filling in for x?
17
Plus 4y. Good. Okay, I asked you guys this question before. How many different letters in this equation now? Just one. That's the whole goal. We simplify it. Now we don't have to think about 2 letters anymore. We're just thinking about 1 letter. Just the letter y. Forget about x for now. We'll come back to x later on. All right. Who can tell me my next step? Distribute what? Okay, what are you distributing? Who can tell me? 2. Positive 2 or negative 2? Positive. Okay, Elijah, go tell me one more time. What's 2 times 17? 34. Yep. Okay. Now we've got 2 times 4y. Travis, what's 2 times 4y? You can, that's okay. 8y. Remember, when you are multiplying, you can multiply anything together that you want. It's only when you're adding and subtracting, you got to have like terms. So we'll actually talk about that in a second. Okay, we still have the plus y. Still have equals negative 2. Okay. William, can you tell me what I could do next? Combine like terms. Okay, what are the like terms? 8y, and how many y's is this? 1. Okay, we're going to combine 8y and 1. Okay, Brian, what do you get when you combine 8y with 1y? 9y. Good. Okay, I got two steps left to get y by itself. Okay, Joe. Yeah, we're going to minus 34 from each side. Okay, Ben, what's negative 2 minus 34? Good, negative 36. Okay, now we're down to our last step, and then we're going to have y.
4 divided by 9
Divide by 9.
on both sides.
Careful.
Negative 4.
Yeah.
Y equals negative 4.
Negative 36 divided by positive 9. What's a negative divided by a positive?
Negative.
Negative. And what, somebody said it. What is it? Negative
4.
4.
Ben said it.
Good. Okay. Any question on that? Question? Scroll up a little bit. Yep.
This is really confusing.
Okay. We got y. Are we done? No. What do we still need to get?
X.
X. So we're going to look back up. Do we got a formula that tells us how to find x? What's the formula for x? X equals what?
Negative 4y equals
X equals what?
17 plus 4y.
Right there. You got a formula right there. Tells you exactly how to find x. X is 17 plus 4y. Okay. Again, why didn't we just plug the negative 4 in to begin with? We didn't have it. Okay, we can't plug it in if we don't have it. Now we have it, we plug it in. So what are we plugging in for y? 4 times what? Victoria? Negative 4. Okay. Let's do it out. We've got 17. What's positive 4 times negative 4?
Negative 16.
Negative 16. Everybody see that? Positive 4 times negative 4, negative 16. Okay. What's my answer for x?
1.
X equals
1.
1. 17 minus 16. 1. Are we done now? Now we're done. Okay, this is the exact same setup for every single problem. So if it seems confusing, at least the one good thing about it, it's never going to change. Ever. It's the same thing every time. Okay? Any questions on that? All right, so we're going to try 2 more of those, and then we'll try to give you time to practice on your own.
Okay, can I try 2B?
You want to do 2B?
Sure, why not? All right. Now, guys, understand that if you want to, and I'm not saying that you have to, if you want to, you can split these. So rather than write them on top of each other, you can write them side by side. You can write them just like this. X. You can write them as, I'm going to use a different color. I'm going to go x plus 2y equals 3. And I'm going to do 3x minus y equals negative 1. Same exact thing. Except rather than written on top of each other, they're written side by side. Because most times, right, we read math left to right. So it's hard to see them, it's a little bit, like there's a lot of information in a small area when you stack them on top of each other. If it works for you when they're stacked on top of each other, you understand that is perfectly fine. If you want to spread them out and do them side by side, that's totally your choice. It's not wrong. There's no right or wrong way to do this. So we got our 2 equations, right? Which letter do we think that we might want to try to solve for? Someone besides Savon. You already answered, but I thank you for that. Benjamin. X. Why X, Ben? Yeah, there's no other, nothing else with it, right? It's by itself. There's no negative sign with it. There's nothing, right? So, Justin, that X, right? He wants to be by himself. He wants nobody else around him. Right now, on that side of the fence, the equal sign of the fence, who's with him? Who's hanging out with him on this side of the fence? The plus sign, and what else? So he doesn't like that 2y. He's like, man, I don't like you. How's he get rid of him? He subtracts him, right? That's kind of like X's version of punching him in the face, right? He subtracts 2y. He subtracts 2y. Right? Marcus, he's not going to sell anybody to slavery. X equals, right? So now, he moved the guy to the other side of the fence, right, Justin? What's on the other side of the fence now? What kind of a 2y? He had to give him the shot, right? Negative 2y, right? Negative 2y plus 3. We're in good shape, right? Benjamin?
How do you get 3 when you get subtraction?
Remember, if there's no sign with a number, we assume that it's positive. If there's no sign with a number, we assume that it's positive. Huh?
So Hager.
I subtracted it, I brought it over here.
Yeah, but what about the one under 3?
There's no y. You can do it either way. If you want to do it this way, if you have,
Did you have 3 minus 2y? Yeah.
if you have, oops, my bad. If you have 3 minus 2y, that's fine too. Either way works. Negative 2 plus 3y means the same as 3 minus 2y. It's the same exact thing. Now, you got to understand, when you get it like this, you have it by itself now. This information can only do the job of what letter? This information, 3 minus 2y, can only do the job of x. All right, it can't do anything else. Like some of you guys in shop. Some of you are like really, I know you're just learning it. Some of you might be really good at like baking if you're in shop, in culinary. You might only be good at baking. That's your one job. Or like Justin, he likes race cars. Some guys in the pit crew, they just do tires. So this guy, right, all this can do is like, think of it as Justin, he can just do tires. That's it. The only job he can do on the pit crew. He can't do anything else. He can't talk to the driver. He can't do any of that stuff. He can only do that one job, and that's it. Just like football, right? Tom Brady. You don't expect him to play the offensive line. You don't expect him to play running back. You don't expect him to play defense. He has one job, play quarterback. Just like when you substitute. This information can only do the job of x. So we're going to plug it into the other equation. All right? What's that other equation going to look like? This other equation, what number is it going to start with, Joe? This other equation, what numbers are it going to start with? 3. Very good. After that, Eli, is going to be what? Parentheses. Good. Inside those parentheses will be what, Eli? 3 subtract 2y and parentheses. The x is out of here. He's gone. Right? Someone took his job. After that, it's going to be what, Tyler? After that, the parentheses comes what? We took the 3, wrote it in, plugged in the information for x. X is gone, right? What comes after x in that equation? We're going to minus y, I heard you, Victoria, equals negative 1. Again, the x can only do, this information can only do x's job. It comes in for x. Everything else in that equation stays. The only thing that's gonna leave is the x. He lost his job, everybody else got to keep their job. Okay? So, why? What am I gonna do now? What's my next step? Here. Huh? Distribute, I'm gonna get what? Yep. That equals -1, right? Shelby, now what? Combine the lines, how many do I get? Or how many do I owe? -7, very good. -7y equals -1, right? Which one of these things is not like the two others? Marcus?
9.
Which one is not like the two other things? Which one's a variable?
-7.
-7y. He stays put. He's happy where he is. Who doesn't have -7y like? Marcus.
9.
He doesn't like the 9, right? So he's going to give it a shot. What's the shot that he gives it? -9, right? That gets rid of him, right? Where does he get thrown?
Over the negative.
At the side of the equal sign, right? I got -7y equals
8, 10.
-10. Last step. Divide by what?
By -7.
What you talking about, Willis? All right. So now, y equals,
10 over -7.
and the top and the bottom are both negative? Positive. Good, Caleb. 10 over 7. Solution. Right here. Now, Martin, with that y, what am I going to do? Huh? Take the 10 over 7. Where's he going to go? Remember, like I told you. Huh? It's going to go for x or y? Y, right? Remember, the y, he's done one too many things wrong, like I told you downstairs. He's done one too many things wrong. He's like, hey, brother, like, I need you to take the rap for me on this. Like, 10 over 7. Hook me up, man. I'm in trouble. The law's after me. Help me out. Take my rap. Where's he going to go? Huh?
So many prison analogies.
Gonna try to make it fun somehow, say
It's
Mark.
no violence too.
All right, here we go. So we got y equals 10 over 7. Where's he going, Ryan? For the y. Which equation you want to put him in? This one or that one? The one on the right. Okay, so what am I going to write? 3. Good. Yeah. Nice job. -1. All right, now, understand, what can I put around that 10 over 7? Parentheses, right? So I get 3x equals -10 over 7. Understand, this is going to be, oh, I'm sorry, I screwed up. Oh, no, I didn't. Never mind. Comes into that, equals -1. All right, now what will we do here? What will we do here, guys? No. What do we want to get by, in this part, what do we want to get by itself? The 3x, right? What's with it? What's with it? -10 over 7, right? How do we get it to the other side? Punch it over, right? Punch it over the fence. 3x equals, if we had a calculator, we could figure it out, right? Last step we would take is divide by 3, right? Mr. Hager, he knows how to use this calculator thing, so I don't want to do that. He's better at that than me. He's the calculator guy.
Okay, what I'm going to do, I'm going to leave it as a fraction, because that's how the book did it. So we've got -1. How do you write -1 as a fraction? Let's do it over 1. What would that be the same as if I made it a denominator of 7? Because I got to have a denominator of 7.
-7 over 7.
Yeah. So instead of writing it as -1 over 1, I'm going to write it as -7 over 7 because of that 7. All right, so let's take 3x. What did we just say negative 1 becomes? So we have negative 7 over 7 plus 10 over 7. Okay, now we've got a common denominator. What's negative 7 plus 10? Negative 3. What's my denominator? 7. And now the last step, what did Mr. Roy just say to do to get rid of this 3 next to the x? Divide by 3. Okay, guys, I need you with me. Thank you. Divide by 3. Divide by 3. Okay, so you're going to get x equals, actually that's positive 3. Negative 7 plus 10 is positive 3. Okay, what do you get when you take 3/7 and divide by 3? It's a little tricky because it's a fraction.
When you divide 3 by 7, you divide by 3.
Yeah, it's the same. I heard somebody say dividing it by 3 just means to take a third of it.
Don't you make it an improper fraction?
You could also make it an improper, well, yeah, you could make it an improper fraction. All right, now I want to go back and look at this for a second because Mr. Roy asked, where should we fill in y? Okay? I don't like where we filled it in. I think we made it harder. We had to deal with all these fractions. Where should we have filled y? Filling it in where we did was okay. But where should we have filled it in? That would have made it easier because x was already alone. Okay, guys, does anybody see where we should have put y in? Okay, I think people are going to get confused because the way that somebody suggested to do this problem is not the way I showed you how to do the last problem. So now you're like, now you're lost. Okay, let me show you. Okay, I think Ryan gave us a suggestion which works. I would have done this. Fill in y in the equation that already has x by itself. Then you don't need to deal with this 3. Okay? Then all you have to do is take y, double it, and do 3 minus 2y. Okay? I think we need to go through another one again. Okay? All right, I want you guys to look at 2c. Okay? And I'm going to show you how to do it. And I want you to try to follow these steps. Okay? The steps I'm going to show you are going to make it easier. Okay. All right, so now we have 2 equations. Okay? We have to choose which variable we want to get by itself.
I just noticed that, like, on the last Hager, do you have to simplify the fraction?
R2C is different than that.
Simplify the fraction? You could.
R2C is different than that.
No, not right now. No.
Mr. Hager, R2C is
Okay.
different than that one.
Yeah, I changed 2c because the one on your paper is a little too hard.
Okay.
So I want you guys to copy this down for 2c.
Should we just erase it?
Yeah, just put a line through the one that's on the paper. Okay, somebody made the point that you can reduce this. I agree, you can make it 1/7. I'm not worried about reducing it because I think that problem we started to get a little confused on. We didn't do anything wrong. We did everything right. Let me show you a little easier way. All right. Look at your top equation. Look at your bottom equation. Does anybody see a letter? Okay, Ryan? A letter that has a 1, an invisible 1 in front of it. X, where?
This is the second.
On the bottom. Okay? If you can find a letter that has an invisible 1 in front of it, that's the one you want to solve for. Okay? So let's take this equation. I'm going to write it off to the side like Mr. Roy did in a second. How would you get x by itself here? Add 2y. Add 2y. Okay. Negative 2y plus 2y. What happens? Cancels out. Can you combine negative 11 with 2y? No. So you get x equals, what's on the other side?
11, negative 11.
Negative 11
Plus 2y.
plus 2y. Okay. Now we've got a letter by itself. Which letter did we get by itself? X. Okay, so now what do I do with this negative 11 plus 2y? Fill it in. Yeah, where is it going to get filled in?
The 2, 2x.
Yeah, it's going to get filled in for which letter? X. Right there. Okay? So you get x by itself, and then you're going to fill it back in the other equation. So we've got a 2. Always put down your parentheses so you don't forget, because certain property is going to come up here. What do we still have on the, what's going to come after the parentheses? Minus y. What's on the other side? Equals negative 1. Okay. What are we filling in for x? Good. Negative 11 plus 2y. All right. Now, what do I do from here? Distribute what? The 2. Okay, is it a positive 2 or negative 2? Positive 2. Okay, what's positive 2 times negative 11?
Negative 22.
Good. What's positive 2 times positive 2y?
4y.
Positive 4y? Everyone agree with that? Positive times positive. Okay, you still get the minus y equals negative 1. Okay, before we do anything with the 22, there's something else on this left-hand side. I see 2 y's that are separate. I can combine them. Okay, Ryan, what's 4y? Take away y. 3y. Good. 3y. Okay, now we can do something with the 22. We're going to plus 22. Where else am I going to plus 22? Negative 1. Good. Okay, before anybody says it, I want to give people a second to just kind of catch up. Okay, now Spencer, can you tell me what my equation is going to be now? 3y equals, how'd you get 21? You took negative 1 and added 22? Or 22 minus 1? Yeah, you can do it that way, that's fine. Yep, divide by 3, don't say the answer yet. So we divide each side by 3, we're going to get a nice answer this time. Yeah, Ben?
7.
What equals 7? What? I don't know what that is though. Y. Okay, it's very important when you write your answer, since you've got one's x, one's y, you've got to say that 7 is the y. Okay, are we done? Okay. Now here's the step I want to point out. that we're going to do a little different. Okay? What we did in the last problem, I want to make it clear, it wasn't wrong. What we did was fine. I just want to suggest an easier way. Okay? So now you're going to fill this y in somewhere. You're going to fill this y in. Okay? You've got a choice. You could fill it in back in the top equation, which is what we did in the last problem, or you can fill it in this one. Why is this one a better choice?
Easy.
Yeah, it's easier. The reason it's easier is because you already did all the work to get x by itself. If you fill in y, then it's just arithmetic. X is already alone. So it's negative 11 plus 2. What are we filling in for y? 7. Watch how easy it's going to be. Negative 11. What's 2 times 7? 14. And what's negative 11 plus 14? Or think of it as 14 take away 11. 3. Okay, so now you might say, well, why didn't we just do that on the last problem? That still wouldn't have avoided fractions. You still would have had to deal with fractions on the last problem. But that's how I would suggest it. Okay. Any questions on
Guys,
that?
like Mr. Hager was saying, when I did mine, I went back to the original equation. You don't have to do that. Because when you rearrange like this x equals negative 11 plus 2y, that was the same as the original equation, you just rearranged it. All right? That was the same as x minus 2y equals negative 11. This, and this are the same thing, just rearranged. That's all it is. So, Mr. Hager makes a good point. Why go back into something where, you have stuff on both sides of the equation? This one, once you do the math on this side, you're going to get x. You don't have to move anything. Just add in, do your multiplication with y, add those two things together, it'll give you what x is. You don't have to move anything.
And you did all that work to get x by itself. So like
So
Mr. Roy
might as
said,
well use
reuse it. Reuse it. You already got x alone. It makes it easier. Okay? Okay, any questions on that one? All right, so tonight you guys have the homework from last night. Okay, it's the same.
Let's do that do now.
It's the same worksheet, except now you're going to do numbers 5 through 8. Okay, so we're going to give you guys some time in class to practice, but that'll be the homework for tonight.
Wait,